As of today, we have, let's say, 565 people who have been into space. Tomorrow, we're going back to the moon. We are going to mine asteroids and a journey to Mars. We're talking about the moon gateway, potentially Mars colonization, and the future. Until now, there is no direct, effective radiation protection system on board the spacecrafts.
This project is the outcome of 25 years of passion for space exploration and 15 years of experience dealing with complex technologies. Today we all confront the reality of deep space exploration, and we know radiation is the most dangerous aspect. Protecting the crews and the onboard electronic, traveling to asteroids, the moon, Mars and beyond, this is the mission we are working on. And with this mission we aim high. We aim at breaking R&D barriers and making the unknown of radiation protection now.
Good afternoon, ladies and gentlemen. I'm Cedric. Basically, I'm the head of system engineering for EmTDLab Space Division. It's not only about 25 years of passion for space exploration that leads me here today, but it's, I would say, 15 years of experience in dealing with complex technologies. I've been exposed either before graduation into technologies like particle accelerator miniaturization, very early days as well into nanotechnologies, and one of the first to calculate catalysis cost for carbon nanotubes, then later on in quite a deep dive into building materials and into advanced materials mainly, which are again catalysis, thin film products, rechargeable battery materials, and here again nanoparticles, which are platinum for cancer therapy. More recently, it was about integration into electronics, chemistry and biology, and again nanoparticles, into biosensing, which were an inventor as well for medical devices using gold nanoparticle. And EmTDLab Space Division is actually the outcome of that 25 years and 15 years journey. Our solution, it's integrated. Integrated, and we have to see the 3 layers of the solution. The first layer is to think about how we tackle what we name TRIPS. TRIPS stands for Thermal, Radiation, Impact and Protective System. So we tackle heat insulation, radiation from space, impact from meteoroids and debris, and finally into a protective system. The second layer we work in It's contrary to the competition, and that's one of our critical success factors, is not to jump immediately into the cross-sectional modeling and Monte Carlo simulation. We will start ab initio, one step further. The third layer of the solution is on the research side, is to make extensive use of materials data science, again something which is not done today, and on the development side is to take profit of cheaper, more affordable, high throughput manufacturing for the pre-production unit, for instance. Okay, revenue side, 3 streams. The first stream seems obvious, that we are small to start, so contract research organization for international private public aerospace organization. Secondly, of course, developing our own custom materials for Earth, airplanes and space at the end. And finally, serving here the local market in Singapore with new advanced methods for performance materials analysis and testing on ground. Let's look at the business case. So Boeing developed advanced thermal protection system. In our case, instead of being just the thermal system, it would be the TRIPS, so radiation included with impact. That was a 16-month contract valued at $14.0 million US. If we go down the road and we look at the extension of this business model, so not only the thermal protection and debris protection, but that we would have a layer inside the pressurized hull of, let's say, Orion, and say we have a company which exists, but in this case, what they produce is neutron-absorbing bricks for Earth application. If we use the market price of those bricks and we build the layer of insulation radiation shield inside the Orion, and again, assuming we build 3 Orion modules, which is the truth, that would lead us to a contract over 3 years of $31.35 million US. Where are we now? So EmTDLab was founded in June 2018. We have completed TRL1, so in space stands for Technology Readiness Level 1. And of course, if you want to fly something, we need to reach TRL9. So currently, we are in a crowdfunding campaign where we want to cover the first part of the Technology Readiness Level 2, and after that, potentially seeking funding as well for the second part of TRL2. On the revenue side, we don't expect to go to space first, but 40 months after inception, I would say this is public launch today, we could expect already to have some revenues from materials for earthbound application. So how can you help us today? We are looking for corporate sponsor during the crowdfunding campaign, which is now. We also welcome grants from the Singapore government to match part of our funding until now. And the third thing, we can also welcome potentially a pre-game changer or 2 pre-game changer investor to help us to accelerate TRL2. So you have seen complex problems, radiation in space, but with doable solution. We can work together. You can help us to accelerate TRL2. We are the only privately funded, Southeast Asia-based, non-academia, non-military venture working on that topic for now. And in fact, we believe we are advancing the future in space. Thank you.
Any questions from the judges? Anyone?
Thank you for your presentation.
Welcome.
Can you go back to the slide where you had the applications in other, on some of the terrestrial industries, like the aerospace one, and then I think there was one other one.
You mean the solution or my previous background in applications?
It was maybe the second or third slide. I'll let you know. Just wanted to confirm something. I think it was that one.
Is it?
No, the one right after this. After this?
Oh, sorry.
Yeah. Next one? Yeah.
Yeah.
So how big of a market are the second and the third one?
Yeah. Let's have a look into the appendix. So all the detailed calculation is available in the appendix. So if we look specifically to the advanced materials market, so I spare you the details of the total value of the market, but target market for this aerospace advanced material size, we talk about 25.8 billion. So this is a figure from Markets and Markets. This is a forecast for 2022 with a growth rate of approximately 7%.
What type of material are they currently using?
Actually, That's a very good question. So basically, aluminium for shielding is still the good old methodology. So if I spare all the Kevlar and polyethylene, the big problem with aluminium is that it creates secondary radiation. This is a problem we do not really mention, but that apart from shielding from the proton, electrons, and galactic cosmic ray, one of the biggest problems for you and your DNA is that those particles, high-energy particles, are generating neutrons as a secondary radiation. So aluminium is still the good old one, and if you ask me how today we protect the crews inside Orion and Artemis, it's currently indirect. It's packing food and water, because water is rich in hydrogen, and protect from radiation, and that's the way today we anticipate to protect astronauts from the radiations.
Thank you.
Welcome.
So, can I ask them what manufacturing capability do you have? Would you be able to manufacture to the kind of specifications to actually fly things, or are you going to need to work through others to do that?
So of course we do not ambition to build our own factories. I mean, this is way too early stage. I don't have any manufacturing production, so as you can imagine. We don't have to think that it must be too fancy. Basically, it will be a combination of something existing. So the type of capability we look at first would be definitely high throughput manufacturing. So classic sheets, coatings, and at the end the solution will be something into we have the methodologies today. The problem, I really believe, is not to create new manufacturing technologies, but with all the coating techniques, carbon fiber, blah, blah, blah. If you look SpaceX, they are doing fantastic stuff, but really advanced stuff. I don't even believe we need to go that far. I mean.
That's fine. And when you put up your example of a layer structure, I didn't see anything in there which looked like a radiation protection layer, but maybe I didn't quite follow.
So if we go back to, you mean this, the different layers, right?
Yes, yes.
So basically this is hypothetical, but everything here is real. So you can check from NASA and ESA, this is even in your own slide deck. The only part which is completely hypothetical here is to present a kind of sandwich panel. We know sandwich panel is not the good solution because of degassing in space, but we do not want to disclose further because part of TRL2 is to patent our methodologies, and it's very too early stage to start disclosing any further information here.
But that's where you'd put your interesting materials, if you like, for the radiation protection.
Yes.
In that sandwich panel.
But so basically that would be something still, we don't want to reinvent the wheel, we don't want to disrupt, maybe we will disrupt, but we want to use existing things because we cannot beat 60 years of research. So the solution is somewhere here, that's for sure.
Oh, what kind of momentum and traction do you currently have? Who's funding some of your research now?
Sorry, can you repeat the question, please?
Who's currently funding some of your research now? Or what kind of traction with the industry that has expressed interest in such a need for such material technology?
Yep. Okay, thank you for the question. So basically, as you could see, I already have different companies which are profitable. So fundamentally, I've covered TRL1 on my own. So this is completely self-financed with my existing revenues team from my existing companies. And that's why we look for crowdfunding. So basically, donation without equity to fund TRL2. That's what we have for the moment. There is no contact with industry. I mean, I have lots of contact in the advanced materials industry, but this is the day we go public. Again, for confidentiality reasons, we haven't been disclosing anything to the public before today. But being one of the companies been working extensively with Umicore, you may know it. I have strong support from them. They haven't heard about the project since today's press release, but I have access to quite a lot of materials production facilities. Also being Belgian, you may know we have quite a big materials clusters like the Flanders Materials Center that we know very well, we have been working with, so we know where to go when we need to start the first partnerships to do the research at a later stage.
Can you also share about your team?
Yep. So at the moment the team, there's a to-be structure. So you can see some color coding. So in green, this is the existing team, so that includes me, already pre-identified people in the board, mainly on the IP side, tech landscape, legal, finance, project management office, but no, I'm actively need the money for the crowdfunding to have my first 2 scientists to work. Because basically most of the work at the moment is in my head, it's my own experience, but I need manpower to put that into effective. So that's the color coding. Green is the people we have, yellow are the people who have been identified. Thank you.